Welcome back to our discussion of drag. Just to make things complete, here we're looking at the Scratch code step by step. And looking at my numerical recipe again, the first thing I do in this block where I'm computing the linear drag, the effective linear drag on the velocity, is going to depend on Vx and Vy. First I'm going to compute that angle that tells me the direction of my velocity. So I'm saying set phi equal to arctan, atan of Vy over Vx. I'm going to compute the speed. The speed is the square root of Vx times Vx plus Vy times Vy, or more simply, if we had a squared operator, the speed is the square root of Vx squared plus Vy squared. As I mentioned in the last video, I could just say speed squared as a separate variable is equal to the sum of Vx squared and Vy squared, but here I have it with the square root. I'll square it later, as you can see. I'm going to choose some drag coefficient, which we'll have to find empirically when we're working with our rocket, but this is my drag coefficient. And then Vx is going to be updated. Vx is what it used to be, plus the drag coefficient times speed squared times dt. And I know when we talked about this a few days ago, we were looking at ux over magnitude of u, Vx over magnitude of v, but I really think that just using this trig function, which we associate with the adjacent and opposite sides of that triangle, really makes things a lot clearer. So we can split the calculation into two parts, calculation of the angle, and then calculation of the two components using that trig function, combination of trig functions to find the x and y component. Let's make our moonscape here a little bit bigger so we can watch the code in action. Notice that I defined that purple block in my Scratch code for linear drag, and because I had a code already working and just wanted to add drag, it's very modular. I just compute the influence here, you can see, of gravity, where I'm pointing on Vy, and then compute the effective linear drag separately. So let's watch it in action. Clicking the flag, let me take a launch speed of, say, 120 meters per second. I'm going to launch at 50-degree launch angle. And here you can see the rocket moving through. I don't know why there's so much drag. If it's on the moon, there's no atmosphere there. But this is your world. Anything you imagine might be able to happen in your code. And I see this characteristic asymmetric curve with a very steep descent. And the rocket is saying, hey, I went 273.41 meters on this launch. I hope that's helpful. Please let me know if you have any questions.